Okay, so this is the second part, or second problem in the video series. I have to get my piece of paper that I've written this out on. Okay, so again, I'm going to start this problem the same way. It says that butanol boils at 118 degrees. So degree C is a temperature. So temperature is 118 degrees C. And I'm even put down TB that indicates boiling. I have a delta H of vaporization of 50 kilojoules per mole. It wants to know what is the butanol's pressure, so that's my unknown, if my temperature is 25 degrees C. Forgot to add the little degree mark there. I just added this question. So you're going, but I only have one pressure. How do I only have one pressure? Well, the thing is that the definition of boiling is when the vapor pressure is equal to or greater than that of the atmospheric pressure. So we're going to assume that the pressure at boiling, so I'm going to indicate that, is 1 atmosphere, I should say, 1 atm, and that's equal to 760 millimeters of mercury. Okay. So again, the equation is going to be P2 over P1 is delta H of vaporization over R over 1 over T1 minus 1 over T2. Okay, so because my pressures are divided, the unit doesn't matter. I could have left it as 1 atmosphere. For these problems, most of them are going to be in millimeters of mercury, so I went to millimeters of mercury. The heat of vaporization has to be in joules. So again, the fact that there's 1 times 10 to the third joules per 1 kilojoule gives me 50,000 joules per mole. Okay. Temperature has to be in Kelvin. So for both of these, I'm going to add 273. I get 391 K here. Plus 273 there is 298 K for that one. And R is a constant, which means that value is going to be the same for all of these problems. It's 8.31, and it's in joules per mole K. Okay. So now I'm going to start putting things in. So I've got natural log. Oh, before I do that, I have 2 pressures, 2 temperatures. Again, like the last problem, it's easier mathematically if my unknown is the numerator. So I'm going to make my unknown, which happens to go with this one here as being 2. And therefore, the pressure boiling and the temperature boiling is going to be number 1. Okay? So P2 is what I'm going to be solving for. P1 is 760. My delta H of vaporization was 50,000. R is 8.31. My temperature, my first temperature is the 391. And my second temperature is the 298. Okay. So I'm going to do this problem very much like the last one. The way that was different is it didn't tell me what the pressure was because it said it was boiling. That was the main difference. So again, I have to leave the left-hand side empty. So it's going to be P2 over 760. When I take 50,000 divided by 8.31, I get 6,018.85. And when I do the 391, 1 over 391 minus 1 over 298, I get a negative 0.0007982. And I tend to leave these things in my memory on my calculator or previous answer. Again, one more time, I'm going to leave the left-hand side alone. P2 over 760. When I multiply these two terms together, I get a negative 4.804. Okay. Now I have the right-hand side simplified as much as I can, so I'm going to do the E to both sides. gets rid of the natural log, so I end up with P2 over 760. And this is going to be 0.008169. I'm not very consistent on how many digits I tend to write down. Okay. Now to solve for P2, I multiply both sides by 760, so P2 is going to be 0.008169 divided by times 760. And so I get 6.23, and the units of that is millimeters of mercury. Again, just a quick check, okay? When my temperature was 391, my pressure was 760. I went down in temperature from 391 to 298, so I went down. So my second pressure should be lower than the 760, and it is by a lot. Okay? So I'm going to keep these short. I'm going to go ahead and stop here, and I've got one more problem on the next slide for this also.